Okay, so we now have our last talk of the session, again from the University of Oxford, Dr. Jack Mellors, who's going to talk about complement-mediated enhancement of SARS-CoV-2 neutralisation. Titres.
Yes, thank you for the introduction. So as you may or may not be aware, the complement system has the potential to promote antibody-mediated neutralisation of numerous viruses. But despite its significance, it's typically inactivated during blood collection or prior to use in cellular immunoassays. For example, heat inactivating your samples would do this. So what we wanted to do to further our understanding of SARS-CoV-2 immunity, threat of emerging variants, and development of therapeutics, we asked, could the complement system enhance SARS-CoV-2 neutralization titers or vaccine sera? If so, what are the mechanisms which underpin this? So we used microneutralization assays first of all, and we supplemented vaccine sera with media heat-inactivated FCS as controls or an exogenous complement source. And then we did neutralizations with VICO1, which is similar to wild type, or BA1, infections of Calu3 and Viro E6 cells, and then had a readout of nucleocapsid staining. So we found in all conditions that complement significantly enhanced neutralization, and in some instances, cross-reactivity against BA1 was completely dependent on the presence of complement, and we saw increases up to an 83-fold enhancement as well in some instances. So looking into the mechanism, there's 4 mechanisms commonly reported within the literature, which we started to dissect. One was looking at the effect of heat inactivation of our complement source and the timing, and we found that if we heat inactivated the source, we significantly saw drops in neutralization, and this was occurring within 2 hours of infection of the cells. We did inhibition of C3, which is a central component of the complement pathway, and found that if we inhibited this, we saw significant reductions in neutralization, but not all the way back to the control, which suggests that maybe some of the upstream proteins alone may be responsible for this. We did ACE2 inhibition assays, and we found that ACE2 spike inhibition was partially responsible for the effects of complement that we were seeing. We did some transmission EM to see whether we could see any viral lysis or aggregation, but this didn't seem to be the possible mechanism to explain this. We used a secondary cohort and basically found that only a few of these actually responded to complement to show that this is something which varies within our cohorts and significantly varies between cohorts as well. So it's not something that just happens for all immune serum samples. And we're now looking at antibody characteristics, so IgG subclass, epitope binding, antibody-dependent complement deposition assays to see what it is that might be influencing these mechanisms. So if you want to know more, I'm post at 16, and please come chat to me. Thank you.